So good morning, everybody. Can you hear me loud and clear?
Yes,
Good
it's
morning.
clear,
Yes,
Chief.
Chief. Good morning, Chief.
Good morning, Chief. Yes, it's
Yeah,
clear.
good morning. So let us start. Last class, we stopped here. The second order of moment, as we know that we compensate first order and the second order. And second order moment, we have the mass which is rotating twice the speed of the crankshaft, and the vertical forces it opposing each other. So the imbalance forces produced by the engine, which will be cancelled out by these two mass, and these two mass will rotate in opposite direction. So the resultant will be together, and that resultant will be opposing this, and it is cancelled out. And this mass for the secondary moment, the mass is calculated for, there is a formula for secondary moment mass to calculate. Based on that, that mass is calculated, and then this two mass is divided by 2. It means this sum of these two masses will be same mass, and then the secondary moment is cancelled out. And first order of moment, it is the like we have in the jockey wheel, which is chain tensioner. Usually we have that, and then diameter will be same diameter of this. Here also, if you see the total diameter, it will be, distance will be similar to this. If you draw a vertical line, total distance, it will be like this, the sprocket of this. So the secondary, up to secondary, we do cancel out, and reciprocating forces. Now, one thing we should know, that is the reciprocating forces. It changes the magnitude, but it does not change the. It means the direction. It is constant, same direction. It is moving on the axis. But whereas for the rotating mass is same, because we have divided the mass. How much mass will be putting on the crank pin? So that mass remain constant, but the direction is continuously, it is changing because it is in rotation, it is rotating. So this is two difference in the reciprocating forces and the centrifugal forces. So in centrifugal forces, it will, because of the angle is changing, it will vary. Whereas for this reciprocating masses, it will be magnitude will vary, but the direction will remain same. But centrifugal, the direction will change, but the magnitude will remain same. So the vertical component we do cancel out. We have seen last class that how the vertical component we do cancel out. It means the secondary, first order also and the secondary also, we vertical component we do cancel out. And the balance compensator weight is calculated. There is a formula to that, and then by that we can calculate, and we give that mass on the, for an example, first order, on the jockey wheel we attach to that, but it has to rotate in opposite direction. And on the, like we have seen this is the jockey wheel, and this is the our crankshaft sprocket. So there will be, for an example, crank pin is here, because we have added this mass. We have considered that this mass is reciprocating mass. We have connecting dot. We have divided, and that mass is added here. And crank pin also has got weight. All this will be here. And then suppose it is rotating in this direction. Then what will happen? There will be a centrifugal force in this direction and this direction, and these will have at the same, for an example, this is the angle, and this will have an angle here, and this mass is rotating at this point in the opposite direction. So what will happen? This will produce a centrifugal force here, which will have a vertical component in this direction, and this vertical component, where you have here the vertical component will be cancelled out. This will be downward direction, this will be upward direction, and mass will be calculated. This mass will be put here, and depending on upon also the radius. If it is the same diameter, then the mass will be equal. the mass we have considered here, that mass will be equal. So we can get vertical forces uh, cancelled out. So that is the way. And for the 2 omega, that is the secondary one, only thing it will rotate in twice the speed. And then same one, these two, if you see this, these two, these two also will rotate in opposite direction. It means one will be rotating in this direction, another will be rotating in this direction. And when this will rotate in this direction, so when it means chain has to move this way, it means this is rotating in this direction. And the secondary mass, what will happen, that will create a resultant component from these two masses vertically, suppose upward direction. That time the secondary mass crank pin is here, so it will have a centrifugal force in this direction, and that will have a vertical component downward direction. These two will be opposing each other and equal, it will get cancelled out. So that is the way it is. It means, for an example, this is the mass here. So it is having a centrifugal force in this direction. This mass is here at that point. So it will having a centrifugal force in this direction. Both will have a vertical component. That two vertical component will be add together, will be having a vertical component here. And that will oppose this one together. So it will get cancelled out. So the secondary and the first and second order moment we do cancelled out this way. And for the secondary mass, this is the formula is for the secondary mass. Mass of the reciprocating parts divided by the 4 multiplied by the connecting dot divided by the crank length. That is the way we calculate the vertical component, equivalent vertical component mass of the second order. So then we know how much is the mass, and then equivalent mass, and then we can divide into 2 and we put it here. It means this equivalent mass divided by 2 is this, equivalent mass divided by 2 is this. This is the secondary moment. And the rotation we have seen, it is twice the engine speed, that is 2 omega it is. And then it gets cancelled out. And like 4-stroke engine, how do we cancel out? We have seen already, we have completed that. The crank wave, at the crank wave, we put a mass. So this is the crank pin, and this is the wave, this is the journal pin, and exactly in the wave, opposite side, we put a mass. So then also it does the same thing. But this mass and this mass, it means it will depend at what distance we are putting. So this mass multiplied by that distance will be the equal to the mass multiplied by this mass multiplied by this distance. So we can balance 4-stroke engine, we do balance this way. So that is the crank wave counter weight we put. Nowadays actually this crankshaft is made such a way it can be incorporated in the wave. There is might not be additional counterweight. The weight is kept such a way so that some weight is attached to the means it is an integral part of the wave. It can be this mass. And if we can reduce the mass as minimum as possible, then this weight also is reduced. Like for us, the 2-stroke engine, we don't use this arrangement. 4-stroke engine, we do use this arrangement. So we have a counter mass exactly opposite. So the centrifugal force in this direction, it gets cancelled out. And the vertical component means it's the force, centrifugal force itself gets cancelled out. So this is the combination of both. It means we have the combination, this is the secondary mass, this is the primary mass. So both the first order and the second order is been cancelled out. This engine is balanced up to second order, first order, second order, first order. If you see this diameter, it will be exactly this diameter. And this, if you see, if you draw a line, it will be this. Why it is so? So that the resultant, what I had shown you, that will come at the center. So that this word force at the center, it will get cancelled out. So that is the reason it is make that way. Now the condition check of the chain, what we check, the 3-point contact by the roller. What is the 3-point contact? Our sprocket is like this. So roller, when it engage, then what will happen? First it comes into this point. So this is a point of contact. After that, when it is turning, it will have a contact at this point. That is the, if you see our sprocket like this. So first it will come here. So there will be a contact point here. After that it is moving. So it will make a contact here because there will be a rolling motion. And when it is leaving, it will be a contact here. So this 3-point contact we must check for the wear down. If it is damaged, how much is the wear? It has to be checked. Then the excessive wear, that is the misalignment, because if there is a vibration, then what will happen? There will be excessive wear. And there will be, if it is a misalignment also, it will be excessive wear because the load distribution will not be equal. Lubrication is poor, lube oil condition is poor, or suppose the nozzle hole is choked, then there will be lack of lubrication. Then also it can, the excessive wear, it can happen. Then the oil discharge, that is the hole is the nozzle hole is suppose partially choked or the fully choked, then it will happen. Then chain link is the you need to check that we have seen that chain link of the riveted link, so that is the outer plate, that has to be checked. All the rivet is intact, rollers are free, smoothly it is by hand you can move it, so no crack. All this chain link you need to, because chain link is very stress, stress is coming onto the, because it is under stretch always, so there can be case when the crack produce, so that you need to visually check if there is any crack. And if there is a crack, then you'll have to do the die checks to confirm that is, yes, there is a crack. And this crack can be in orientation, because this has got a hole where we have the rivet. So it can be radially, it can be even on the line of the hole also. And in this place also you can have crack. So these all cracks you need to visually check. Then rubber guides for the bar. We have seen the unsupported area where the chain length is unsupported like this. So this is unsupported long length. So there will be a guide bar and there will be rubber padding, which is the shock absorber. So that condition you must also check. And this is secured by the clamping. So that's secured on the A-frame. So that also you need to check that it is properly secure or not. So guide bar support, that is the first fastening, because the guide bar support also, because guide bar is guiding the chain and there is a support which guide bar should not move, so that support also you must check. Then chain tension, we check manually. We have seen how do we check the chain tension, that one link or the half link is minimum, one link is maximum. Then chain adjuster bolt, that we have done the chain adjustment of the tension, that bolt is, we have locked it and tightened, and we have the locking washer, that also has to be checked. Then lubrication, you start the pump and you see all the pipes also is fastened properly, and then we start the pump and we check the holes are free because jet is coming out. So now, there can be vibration of the chain. What can be the reason? for vibration of the chain, which will have an adverse effect. Chain can break. So one thing is if it is slackened. If it is slack, you need to retighten the, it means tensioning has to be done. Misalignment of the wheel. How do you check that? It means on the side of the sprocket. For an example, this is the camshaft sprocket, this is the crankshaft sprocket. So we can put a piano wear. By putting a piano wear from top to bottom, now if you see from the side, this will be the one, for an example, this is the one camshaft wheel and this is the crankshaft wheel. If you have the piano wire, you're putting like this, if it is aligned, so this gap will not be there and it will be even, means there will not be any gap, both will be throughout the sprocket, it will touch the sprocket so that it is aligned. You must check that, and with the, if it is close, we can see by the scale also. But since the length is more, because BMW uses the chain drive, the camshaft is on the higher side, so you can put a piano wire and you can check. And then the chain twisting. If it is chain twisting, how will you check that? It means if you hang it, then the chain, if it twist it, it will be, if it is hanging, chain will be like this. If it is not, then in between there will be, it means it will not be a straight line. So you will see that chain is twisted. It will be at certain angle, some portion of the chain. Then seizure of the pin. So we need to renew the link if it is seized. We know where it can seize. The roller is the bush and then the roller. If bush and roller is seized, it means we'll have to change the link. Uneven chain length, multi drive. When you are using the two chain, it means it is a multi drive and one chain has got worn out differently than the other, then you will be having uneven chain length. Then you need to change the, match the chain. It means both the chain length, everything has to be same. That's why when it is a more than one chain is used, that time you'll have to be careful that the, it should own out similarly. If not, then you'll have to adjust the chain length such a way so that it become equal. Otherwise, you'll have the vibration. Roller, if it is jam, what is the problem? Roller, it is jam, then there will not be any rolling motion. There will be a dragging motion. So it will drag the frictional force. Rolling motion, the friction is very, very less because it is only one line it in contact. So if it is wheel is suppose the damage, then what you can do, it can be actually roller also can be jam in the wheel. Suppose wheel is, this is the sprocket and it is roller is not turning because there is this sprocket tip is damaged. Because of that, it is not. So how do you dress it? We have the mandrel. It means mandrel is provided by the maker. This is the circular, and with the mandrel only you should dress. So it will cut the excess roughness of the surface. It will become smooth, and this circle it will make this curvature. It will make exactly same curvature as per the mandrel. Then the vibration, if excessive vibration at sea, stop the engine and then inspect it, correct the tension, and then make it port. It means then you restart the engine, because this is one thing. If it get damaged without chain and you don't have a link or some spare, can you run the engine? We won't be able to connect it. Even if you able to connect, you use the same used one, what will happen? You'll have to reduce the load, maybe like slow head, dead slow, like that, to make a port. So that's why if excessive vibration, you must stop it and you must tighten the chain and then took a correct tension so that vibration reduces. And in port, then reason of the vibration, you have made the ship in port, and then you must investigate what is the problem of the actual problem of the vibration, and then you must uh, rectify it. Never, as I told you, the assembling link more than once do not use, because once you have made the rivet and then you have removed that, and that rivet you won't be able to again, that strength is lost, because and the length of the pin also lost. Match to the chain, always there is marking. It means how to put it, which one. It means it is one piece, because even if you have a plate where actually the pin is entering from here, so this plate you can make it turn, but don't turn. There is marking, because this hole might not be exactly the same. Because when you do the machining, there can be a tolerance. So they keep marking. So which pin will go to which hole. So exactly check the match marking, accordingly you assemble it, and it has to be, and serial number has also is there, direction is there, arrow pointing, so that you know exactly serial number why it is put, because you have the other side which will match to a particular link plate. Do not interchange, then this interference will be lost, and there will be stress generated will be high. So multi-strand chain, we have seen that the permission, this is the permissible elongation. It is 1%, we have seen, and the multi-strand change, it means if you have the two link, it means you have the outer plate here, inner plate here, and then another inner plate here, we have the outer plate, and another inner plate, another inner plate, another outer plate, and you can have one pin. So it is duplex, two chain together. So in that case, it should get worn out together at same rate. Then maximum tooth wear flank, we have seen that profile gauge. We have put the profile gauge and we check the uh, clearance. So this is the standard, this is the clearance of some of the engines, example like 25 millimeter, 0.87, this clearance will be 0.875. Then 50, 1.625. 75, that is the chain pitch basically, and 100 is the 4-inch chain, 3.5. So new chain and the badly owned wheel do not put. If you are putting a new chain, if your wheel is sprocket wheel is worn out, we'll have to change both together. Otherwise, again, your chain will get damaged, which we don't want, because once you are changing the chain together, you'll have to change the wheel. And we have seen the safety factor, that is 25, we know. Then the tensioner, if this is the slack side of the chain, we put the chain tensioner is fitted so that you can do the tensioning. And then tensile strength, it is the chain, it varies a square of the link pitch. So we consider how much length of the chain we give, because tensile strength is fixed for us. Polygon effect, we have seen that jerky moment, that's the reason 17 to 23, we give the number of teeth. We have already seen that. Then the length, the alteration of the length is 0.62 L by N square, whereas the L is the chain link, number of teeth is N. What is this? We have seen the polygon effect, the length is, the distance is changing. So this is the center point. Once the roller is here, next moment roller is here. So this distance changes. So v minimum is here and v maximum is here. V is the speed, linear speed of the chain, and this is the speed. And this distance, alteration of distance, follow this formula. And polygon effect, that's why Another thing we have seen that the center to center distance of the sprocket, we keep the multiply of the chain pitch. So to avoid, minimize this effect. Now there is slow speed two-stroke camshaft. Camshaft, how it is, yeah, how it is constructed. So why this camshaft? There is a cam which is on the camshaft, and uh, it gives the correct timing for the fuel pump and the exhaust valve. And this camshaft is made in section. So and then it is coupled together. There are different type of a couple. Uh, we can have flange couple also. You can have sleeve. We can have uh, another type of, that is the sleeve. We can have that couple also. We can have. So then individual cam actually is manufactured by the still, and it is shrunk fit on the uh, on your camshaft. So this cam, the surface is heat treated because it has to make very hard, because there should not be any deformation on the surface. But that is the case hardening is done. But internal remain tough. We have seen the heat treatment, the case hardening or the surface hardening, and the cam is also done same way. So that the surface is very hard, because the load is coming onto the cam. It should not get deformed. It remains in the same profile. Profile changes, your timing will change. And it has to be at the correct position. So exactly on the same correct angle, it is shrink fit on the camshaft. And this camshaft is in section. It means it is in segment. Like for each unit, for an example, one camshaft you make, and then you join together. It can be for a soldier, 2 unit, they make one section. For an example, let us see this diagram. So here, there is a coupling. In this part, this has got two fuel cam, two exhaust valve cam. And you have another coupling here. So for 2 unit, one section they have. It can be 1 unit, one section also. It depends upon the design, but it will be in section. And now we have put the cam. It means cam is a separate piece. It is shrunk fit. So now we cannot, our shaft has to be here like this. Then only we can put the cam here. Otherwise, we won't be able to put it. If you have a flange, we cannot put. But I said that flange, we coupled by the flange or the sleeve. This is a different type. I'll explain to you this. So the flange means it will be a flange which is separate piece. So there will be a flange here. And this flange is shrunk fit, and you can remove it by hydraulic pressure. Like this, also we have put it inside. It means we can put it, the cam, we have, suppose here 4 cams, cam is there. We put the 4 cam and both side, then we put a flange, which is actually a different piece. It's not integral part of the uh, shaft. Unlike like we have the intermediate shaft, crankshaft, the flange is integral part of the shaft. Here, this flange, we can remove it. And it is interference fit due to the frictional force. It is remaining in this position. Like this also, cam also, it is because of the frictional force, interference fit, it remains in this position. We don't use the keyway, then the stress, it is a stress riser, you can have crack in that. So in our case, in our engine, we don't use the key and keyway. So this is the way it is made, so that it is in segments or the sections. So each here soldier, they use 2 unit, one piece, and then another 2 unit, another piece. This is the another camshaft segment, and then they join together. But soldier, BMW for an example, they use the flange. But soldier, they use different types. Soldier, how they use this coupling? If you see this is the coupling for the soldier. In this case, what they do, there is you see this is a coupling. Inside there is a sleeve. You can see the dark line, that is the sleeve. And this sleeve, this is your shaft. And there is a, let me draw in enlarged view. There is a sleeve here. And this sleeve is taper. You can see here, this distance is less than this distance. And on top, we have one coupling, another sleeve, which we have, if you see this internal surface is taper here. Outside is parallel to the shaft. So what happens if we push it hydraulically, this one in this direction or this one in this direction, then what will happen? Suppose we push it in this direction. Again, this is we are holding with the tool. This we are not allowing it to move. We are pushing this. Then what will happen? Once you are pushing it, our shaft, which is, this is a straight line, and between these two, what will happen? This will move inside. Once this is moving inside, this diameter will reduce because this is taper. Once it is moving inside, internal diameter of the sleeve, inner sleeve, will reduce. That will give a frictional force on the shaft and it will remain in position. So this is called muff coupling. And this one, we can inject oil inside. There are passage. You see, there is passage through which we can inject oil in between the shaft and the our inner sleeve. So that what will happen? The inner sleeve, when you are pushing it with the force, hydraulic force, then this will move inside easily because there is oil inside. After that, you can drain that oil, and then it means the force required will be less and there will not be damage also. Otherwise, because of the rubbing effect, it can get damaged. This is, shafting. It's there in very details. That time I'll teach you in details, but that is the way it can be fixed. It means because of this taper, this is we have given a relative motion between this and this, outer sleeve and inner sleeve. And because of the taper, when inner sleeve is pushing this way, moving this way against this outer sleeve, so what will happen? It means this diameter, for an example, this diameter is more than this diameter. It was here. Now this higher diameter has moved into this space. So throughout the length, it will move exactly the same way. This kind of a coupling, no, there will not be any slippage. The force is how much distance it will travel with the force. This distance is measured, or this distance is measured. There will not be any slip. So they are using for edges. So and even shaft coupling also, other shaft coupling also, we can have this CPP. Those are using. They use this muff coupling. So it will not be. It will depend on how much frictional force it has got here and here. Both sides there will be a frictional force because diameter will reduce because of that force. This outer sleeve will give a force this direction. So there will be a frictional force between the inner and outer sleeve as well as the surface of the shaft and the inner sleeve, inner surface. And how much distance it has moved inside, that will decide how much frictional force. And this distance is measured. It will be given by the manual in the manufacturer that how much distance it will be moving. So they calculate how much force is required to make that grip, frictional grip. It will remain that frictional grip. There will not be slippage if you can assemble properly. So we use this type of coupling as well as the flange coupling, both we do use. And even the flange coupling also interference fit. It means you have the shaft and this is the flange. And this flange, for an example, you make it heat and then put it. But when you remove, there are passage for the oil injection. You inject the oil, this grip is lost. Once between two surface oil is there, friction is lost, and then you can remove it. And even we adjust the timing by injecting this. We don't remove it, we inject it, this frictional force is lost, and then we turn the camshaft so that cam timing is can be adjusted. So this is one of the arrangement for your uh, camshaft. So it is in segment and then it is expanded. It can be hydraulically or it can be heated to expand it, and then we can adjustment. It means if you want to replace, you hydraulically expand and remove it, or you want to adjust the cam timing. Sometime we need to adjust the cam timing. That time we coupling we slacken and then we can turn the camshaft with the cam. Even cam itself also can be adjusted if it is a shrunk fit, and cam also has got a lube oil injection point. There are plugs, so with that you can do it. So the camshaft also, like soldier, for a conventional engine, they have the reversing servo motor, which is uh, uh, it is in the camshaft. Let us see what is that. It means for reversing of the engine, the fuel timing has to be changed. So in that case, we'll have to move the cam relative to the camshaft. Then we are actually move the cam relative to the crankshaft angle. So this is the part which is. So this is the reversing. Next chapter, it is there in details. What it does, this is one fuel cam, this is another fuel cam because it's for two unit, and hydraulically we can shift the cam relative to the camshaft. So that camshaft remain in position, cam we turn for the reversing angle to achieve. Then we reverse the engine. So the conventional engine, they do this way. Whereas for the BMW, they shift the roller instead of doing anything to the cam. They don't do anything to the cam or camshaft. Both way it can be done. Here, this is the reversing servo motor. And then this is the bearing. Camshaft has to be supported by the bearing, and these are the your cam for the your exhaust valve. So exhaust valve cam, we don't do anything. Why? Because it is symmetrical. Whereas fuel cam has to be shifted. We'll see why it has to be shifted, because it is there in your syllabus. So we'll see that. So the camshaft coupling, uh, camshaft coupling. Just all of you, just give me a moment. Let us restart. So this camshaft coupling, when we do the retiming, suppose we have adjusted for some reason, that one of the reason we have seen that the chain gets stretched and then the timing gets retarded. In that case, after suppose we remove two chain link, and then we need to check the timing after doing the tensioning, and then we turn the one revolution of the engine, and then we check the timing. Suppose we found that the timing is not correct, it is retarded. In that case, what we'll do, we'll have to adjust the timing. How we adjust the timing in that case? So what we do, it means we need to now all the, if it is a chain, because of the chain drive it happens, and because of the chain, if the timing is retarded, all the unit timing will be retarded, because it is the common problem. So in that case, we have removed, suppose, two chain link, we have tension is given, correct tension, and we have shifted also one chain link to other side, and then we check the timing. Now we found the timing is not correct. We'll have to correct it. Then in that case, what will happen? For an example, suppose our this is the camshaft, and we can check the timing. There is a pin gauge at the bottom, there is a marking, and there is a pin gauge where these two punch mark is there, it has to match with that. Now this is the center point. For an example, it should be here, but you found it is here, and there is a some 2-degree angle is, usually it is 2 degree, because we are changing maximum length, we are max 1% of the elongation, then equivalent to this will be 2 degree. And suppose the punch mark you find here, it means you'll have to turn it, the camshaft, in this direction, and then only this punch mark should come here. That is the correct timing. Now what we are doing, when we are turning this, and now your cam is mounted on the camshaft, so it will also turn with the camshaft. What we need to do when we are turning this, our crankshaft should not turn. Crankshaft will be in same position, and we'll have to turn this. So what we do, or if you see the arrangement of the camshaft, this is the camshaft, and this is the uh, sprocket wheel, and this sprocket wheel, and you have the chain on the sprocket wheel, but this sprocket wheel and the camshaft, there is a coupling. So there will be a coupling here. So this coupling, and there is a coupling on the sprocket wheel. So this coupling, we can inject the oil. There are holes through which we can inject lube oil. That is, once we inject the lube oil, then what will happen? This flange coupling will expand, and then this sprocket is free from this camshaft. It means camshaft we can turn against the sprocket wheel, and sprocket wheel you have the chain which is tensioned already with the crankshaft sprocket, and you have the turning gear is engaged so that it does not, this side will not turn. So what we do, we slacken this, disconnect this. We don't remove it. Only if you inject the oil, the frictional force is lost. Now we have the flange here, other side of the flange. Suppose this is the, it means now we can turn it. We have the flange on, suppose this is the flange, another flange. It is in section as we have seen. So this is the flange which is having a grip. We have not done anything with that. And this flange has a bolt, because this is a two flange, because this is one section of the camshaft, this is another segment of the camshaft, and end is, for an example, our chain drive is at the end is sprocket is coupled with this camshaft. So this is the camshaft. Now if we can slacken this by injecting the oil, and how, when actually, when you are injecting with the high pressure pump, it is same pump we do use, like we use the high pressure hydraulic pump, that pump, with that we inject this. There are plug, we remove the plug, and then hydraulic hose is connected, and we inject the oil on this, between the flange inner surface and the camshaft. We have this surface, we friction we remove because we inject the oil so that the friction is removed. Once we do so, after that what we do, we hold a spanner here. This spanner, if you see from the this direction, how does it look like? This will be a circle of the flange, and this flange will have at the PCD there will be bolts, and we can have a spanner like this, C spanner, and we can bolt it here. We can secure this spanner here at these two bolts. And then with the chain block or the tackle, we can turn it. What we are actually doing, we have removed the friction here. Now sprocket, if we turn the camshaft, sprocket will not turn. It means there will not be any mechanical interference between the sprocket and the camshaft. Now we put this C spanner. C spanner is like this. It is a heavy spanner. It is provided on the ship. So this spanner, we put it here, and this spanner has got a slot for the bolt. We have the flange bolt here, and one side of the bolt, we secure this too. And then what we are doing with the spanner, we are turning the camshaft. So this is, once you move, for an example, in this direction, what will happen? The flange will turn, and flange is attached to your, it means with having a frictional grip here with the camshaft. So camshaft also will turn. So once you turn it, it means you are turning in this direction. Slowly this punch will come in this direction, and at one point it will coincide here with the pin gauge. Pin gauge, you must keep it, the pin gauge in place when you are turning, and then it will coincide, and that is, then you should do it very slowly. It should not overshoot. Again you'll have to turn back in opposite direction. You'll have to turn slowly. You bring this punch mark on this angle, and your pin gauge will match this punch mark and this punch mark, and that is the correction of the adjustment of the your timing. And suppose, and then what you do, once you have adjusted the timing, after that this has to be this, it means when you are turning continuously, you'll have to supply the oil, and oil will drip out from the flange surface here. It will be dripping. You can see that continuously there has to be dripping, because we don't want any grip on this when you are turning. If you are turning and there is a grip, there will be a mechanical interference. So you'll have to keep on supplying the oil with the hydraulic pump, high pressure pump, so that continuously there is a oil seepage through this surface between the camshaft and the flange inner surface. So that ensured that there is no frictional force here. So we can easily turn it. Sometime we lift the, when you are turning, we lift, usually it's not required, but if you want to reduce the force, you can lift the, for your fuel pump roller, you can lift. It's like cutting out of the unit, we lift the, then the force on the cam will be reduced, which is finally coming to your this thing, the camshaft. But usually it is not required, because it is a roller, also it is rolling motion. You can turn it with that. Is it clear how you adjust the timing? Have you understood what I said? Yeah, Teka, tell me.
Sir, I have a question here.
Yeah, tell me.
This camshaft adjustment is, according to the written there, is because of the, one of the reason is the elongation of the chain.
Yeah.
My question is that which one is more better, to change the chain or to make the timing adjustment? Because I'm thinking that if it is because of the chain elongation, and then when we change the chain by new chain, we should have to change the timing again for the camshaft. And is it really feasible on board the ship to adjust the timing just like this? I have never seen that somebody is doing like this.
Yes. So you see, the makers has asked us to two chain link we can remove. That is, for changing the chain is expensive affairs. So definitely the ship owner will go for the removing the two chain link. After two chain link, if we find we have shifted the one link from one side to other side, we have seen that. After that, if we check the timing is not correct. We'll have to correct it. And this can be done. Actually, it is, but it is not done, it is not something which you every day you do. But if this is the situation when you need to reduce the length of the chain because of the elongation and you need to correct the timing, you need to do. And it can be done on ship. But it will depend on the, it means most owner will go for two chain link removal first because it will be an expensive affair to renew the complete chain. But definitely it will depend on the owner. But most of the owner will go for removing the two chain link to adjust the length. And if you find after that this is the timing is not correct, you'll have to adjust. And this is the procedure for you to do that. And it can be done on ship. It is done, many ships it has been done this way. But the procedure, is it clear to you? All of you? So that you should not do a mistake. Your understanding should be very clear. We have slackened it. Now sprocket will be in place. We can turn the cam. Cam we are turning. We are putting the C clamp here, C spanner, and then we move in the right direction because this flange is friction with the grip, frictional grip. It is attached to your camshaft. We can turn this flange, camshaft is turned, and this punch mark will bring back to this. So that is the correct timing. So this is the way we do. So that yeah, two of you raise your hand. Tell me.
Yes, Chief. Good morning. This is Leo.
Yeah, good morning. Tell me.
Maybe I didn't give attention, or maybe I miss if you say something about this during timing procedure of making resetting the timing. What is really the purpose of this high pressure oil?
Okay. No, say again. What did you ask? You're talking isn't it?
Yes,
Say
this is
again.
Leo.
What is the
It
question?
says here for timing, for readjusting the timing. What is really the purpose of this high pressure oil?
Okay. Purpose of releasing the high pressure oil, are you talking about after the adjustment or during the adjustment?
During the adjustment.
Yeah. During the adjustment, this is the coupling, flange coupling, which has to be detached from the camshaft. So that's why we are injecting the oil. So this is our flange. And this is our, for an example, camshaft. So this oil we inject here, so that we are injecting, there is oil passage is put it on the flange here, as well as there will be 2-3 For an example, 2 is here and one passage is on the flange, on the coupling. So we are injecting the oil. Why we are injecting the oil? We are putting the oil with the high pressure between the camshaft surface and the inner surface of the flange to break that frictional grip. Once you put the oil in between, then what will happen? The frictional grip is lost. Once the frictional grip is lost, then we can turn the camshaft against this flange. Flange is not turning, camshaft is turning. That's why we have put the C spanner here. This is the other side is the sprocket, and this side is the camshaft. So what we have done, we have injected the oil here to remove the frictional grip between the flange and the camshaft, because this flange is flanged with your the sprocket. This is the sprocket. So sprocket, we are not turning, we are turning the camshaft against the sprocket, and we are matching this punch mark. So continuously we'll have to inject oil, and you'll see from this side oil is dripping continuously. So that ensures that the frictional grip is lost, so that we can turn the camshaft against the flange, which is coupled with the sprocket. What does it mean? We are turning the camshaft against the sprocket, and sprocket is driven by the crankshaft. Against the crankshaft, we are turning the camshaft. Is it clear, you, why we have
Yes,
injected in the flange? Now,
yes, it's
after
clear.
the correction, then we need to drain this. Yeah, somebody raise hand. Any
Yes, Chief.
other? Yeah.
Yeah. Why we normally, before we adjusting this, we make #1 unit TDC, yes? Unit #1.
Yes. Yes. We have seen
But what
that it is one of the unit you need to take reference, and that is manufacturer usually keep the reference as #1 unit. That's why previously, last class, I think it has been covered that #1 unit we put it on TDC. So #1 unit we put it on TDC because the makers take the punch mark is marked keeping the reference #1 unit at TDC. That is the reason. Because if you keep another unit, maker has punch mark, this punch mark is when the #1 unit was at TDC. Accordingly, they know, means one unit you take the reference, all unit is corrected. So that is the reason. Because most of the cases, the maker will take the #1 unit at TDC. If maker says no, another unit, you'll have to take that unit at TDC. But it is a thumb rule, all the makers use this #1 unit. But it's not necessary that #1 unit only has to be at TDC as reference. It can be taken from any unit at a particular, so for an example, #2 unit at TDC. Reference is taken. Then accordingly this punch mark will be there. And we have seen the unit TDC also there is a pin gauge to check. That also will be referred to that unit. Understood. It is not necessary, but all the makers, they take #1 unit as a reference for marking this punch mark, and which we cannot change. Once the maker has made a punch mark, and that is final, and he has taken #1 unit.
Okay, thank you, Chief. Okay.
Now, after the adjustment, what we do, we disconnect the high pressure pipe, and then oil will come out. At least around 20, 25, 30, 20 to 30 minutes, you must keep it drained. You must keep it open. And all the oil will slowly will come out. After that, you put back the plug. Here you will see there are plugs. So that plug has to be secured. So after that, it means there is a grip. Grip has again regained, and then now it is in correct position, and engine can be run in normal operation. And when, yeah, tell me.
Okay, thank you, Chief.
Okay, Chief. Thank you.
Yeah.
My question was about this the location of the benchmark. I think it's already answered. And we follow the the manual.
Yeah.
Which unit have to be benchmark, or which unit we have to refer when we are adjusting.
Yeah.
And another benchmark, is it on the airframe? Airframe, I mean. This one of my question, and the other is these camshafts in 4-stroke engine. Is the construction the same, or we have different constructions? Thank you.
The camshaft you're talking about? Yeah, for 4-stroke
Yes.
engine. 4-stroke engine
Yes, is it the
camshaft
same?
is there in your syllabus. I'll come to that. Okay, it is after that there is a 4-stroke engine camshaft construction also is there. Now this punch mark, this one, it is in this diagram what I had drawn. That is, suppose this is the cam case. We have the cam case cover here. If you remove the cover from here, for an example, this side is the cover, and here you have the mark. Some engine they mark here. You have the cam case. In the cam case, when you open the cover to have an access, one side is on the camshaft and the other side on the surface of it means we have opened the cover in this area, and this pin gauge, there is a punch mark here, but it is not necessary it will be here always. So it can be on the side of the engine enterplature also. Because if you see the B&W, where is the camshaft? It is on the upper side. That is on the cylinder block. So side of the cylinder block, you can have, for an example, this is your camshaft. You have one punch mark here, another, you can have a frame here, which is punch mark is here. That is the part of our cylinder block. We can have a punch mark, one here, one here. And this might be the outside of the casing. It means if you see this diagram, it will be clearly given. This is the cam case. Punch mark is here. And another punch mark, if you have, that is 90 degree to this crankshaft. If there is any structure, you can have it there also. So it's not necessary that it will be always on the one I have drawn, it is here. Like in the front, you have a cover, and that cover has got an opening. At the bottom of that, you have this mark. But it can be outside also. So it is not necessary. It will be clearly given in the manual where the punch mark it is. And you can take out the paint and you'll see there is a punch mark. And once you have identified, you make a circle with the different color. Because what happened, we paint the engine many times. So these all is painted. You will not be able to see this punch mark. But when you refer to the manual, you can remove the paint on that area, you will find that punch mark. And then you can make a circle so that you know where is the punch mark with a different color. So, and A-frame punch mark is for the TDC. That particular unit at TDC, that once it is in TDC, your wave will be in this position, and on the wave top there will be a punch mark, and then it will be like this. And this is our A-frame. One mark will be on the A-frame and another will be on the wave. So that is for the TDC. And now for the soldier, they put it lower position. So where it is depend on that. It will be on a fixed structure of the engine. So there one will be camshaft, another one will be on the fixed structure of the engine. For an example, Sulzer, where is the local maneuvering? It is on the fuel pump platform. So that has got a structure. And that is the part that there you can have a punch mark. And that is a part of the engine, that casing. And the camshaft is at the lower. So camshaft and that structure, you can have a 2 punch mark for the camshaft. For BMW, it will be on the higher side, so it will be on the interplacer. It will be on the your cylinder block. So depending on where it is, it will be on a fixed structure of the engine. This point will be punch will be clear. Understood? Anybody? Any other questions?
Yes, it's clear, Chief. Thank you.
Now let us. Yeah. So, somebody wants to speak?
This is Sophonis. Chief, when we are injecting this hydraulic oil, for me, what I understand is we are increasing the clearance between the shaft and the coupling. So, is there any risk of damaging one of the two permanently, so that we will lose the grip? And what should we do not to create such kind of damage?
No, there is no problem, because what the maker says, you inject and it should be dripping from the side. Once you see it is dripping, you can turn it. There is no problem. And this, it should be dripping. Drip means point, like it is coming out not continuously. It will drip, again stop, again drip, like that, and you will be able to make out. And this material design strength is such so that that will not cause any damage, because it is a oil in between. What we are doing actually, this what you are saying is correct. This flange will get expanded because of the hydraulic pressure. But what is our idea? Between the surface, inner surface of the flange and the camshaft, we put the oil to remove that frictional grip. It means why we lubricate? The frictional force will reduce. Same thing we are doing. It means that frictional interference with frictional grip is lost. So that is the reason we inject the oil, but it will not get damaged. The material strength is much higher than that, because this is the procedure for adjusting the timing. It will not damage. Don't worry about that. If you are, suppose you are worried, what will happen? This dripping will be less. You won't be able to turn. It will not turn, because your this sprocket, and in fact there can be a damage, because you are trying to turn the sprocket with the camshaft, and sprocket, there is a chain, camshaft, crankshaft is not turning. So you, once the dripping is done, it's dripping from the side, and it will not get damaged. You should not get worried over that. It will not get damaged. It is design, material design is such.
Okay, thank you, Chief.
Chief, one more thing here.
Tell me.
We will continue filling this hydraulic oil until we finish the timing, or just we will stop after we saw once when oil is dripping?
No, we'll be pumping continuously till we bring that punch mark to the correct position, and it does not take much time.
Okay.
Once you are turning with the tackle, it will be 2 degrees only, and you'll be till then you'll have to keep on pumping, and it will keep on dripping from the side.
Okay.
So next.
Sir, how much is the approximate pressure?
Yeah,
The
this
oil
pressure will not
getting-
given to you. It is saying that it should come out the oil from the side. So it is that pressure is not prescribed in this case. Understood? Because we need to remove that frictional grip, and it is always given that at what pressure, means you can check, but it can vary. that pressure is important, because of that it is coming out. But our requirement is that oil should come out from the side in dripping. Oil should drip from the side, and you'll have to keep on increasing that till it comes out. Understood, Teka?
Okay, sir. Yes.
So now this is the way we have adjusted the timing. Now medium speed engine. And now another thing, this what I had drawn, actually the sprocket, the camshaft sprocket was at the end. If it is at the center, large engine, it is at the center, then what will happen? You do the same thing one side, after that you do the same thing other side. Because in that case, once you are turning the camshaft in one side, other side is not turning. And it will be one by one. One side you finish, after that you remove the tools to other side, and then you turn the camshaft and correct the timing to the other side. Twice you'll have to do. Now, the different method we manufacture the medium speed camshaft. It can be flange also. It can be different way. Let us see what are the way we manufacture. Small engine, the camshaft and the cam is single forging. It means on the camshaft, you can have the forging. In that case, if your cam is damaged, you'll have to change the camshaft. But it is a small engine, it is okay. I mean, it will not be that expensive if it is a large engine. So another way how we can do that, the camshaft build a single shaft, which is cylindrical. And we have the cam separately is made. And once is the, or we can have the flanges. It means each cam shaft, suppose we have the 6 unit, 6 section we make, and then it is flanged and we join flanges. So it is, for an example, 6 cylinder, and we have the bolt, like the bolt hole on the flange is 6. Can we interchange the section? For an example, we have one section here. So we have the camshaft. So for a 6 cylinder, we have a camshaft. And we have made this camshaft one flange here, one flange here, and in between it will be secured by the bolt. We have so for an example, this has got inlet, outlet, that is the inlet and exhaust valve cam, as well as the fuel pump cam. And this is flanged. It means one shaft is up to here, another shaft is after that. Here also it is secured by the bolt, and this flange has got 6 holes, equidistance. For an example, it is the equidistance hole you have all around the flange. So in that case, what will happen if you have the equidistance hole? Suppose one hole here, another here, another here, another here, and here. So it is equidistance. You keep 6 holes. So in that case, my question is, can I use this for another unit? Suppose we want to use, do you need to use exactly the same section to a particular unit? Is my question clear?
Yes, Chief, it's clear.
Can we use, in that case,
No.
we can use. Why? Because our angle will be difference in one between one unit to another unit, that will be same. So what will happen? Only the position of the hole we change. So once we change the position of the hole, we can get a correct angle of that particular unit, because we have 6 hole in 6 unit and equidistance. That is the angle of between 2 hole is same. So what we can do, suppose we want to use this one here. So we'll have to turn it such a way one hole will match, and we can couple it, and that particular cam position we can have it for this unit. So we can, in that case, we can manufacture it. After that, when you are assembling it, that time which hole will be putting, the flange will be coupled, that we can put it such a way so that we can make any section for any particular unit. Yeah,
Chief?
somebody raise hand. Who was that? Tell me.
Yes, it's me, David, Chief. So, Chief, if we do see this kind of stuff, we will disturb the timing for the exhaust and the fuel, no?
No, there will not be any timing problem. Why you have made manufacturing process is easy. And for 6 unit, if you made this way, the cam angle will make for a particular angle, particular position, and that we can change depending on the unit, what will be the timing, we can shift it to that match to that timing. If we have 6 unit, 6 section we make, and 6 hole we make in the flange, we can adjust the any section we can put any for unit. Any unit we can use. Only this hole, suppose for number 1 unit, this hole was coupled with, suppose this is number 1 hole, and the other flange, it was number 1 hole. But for firing sequence, if you see, suppose 1 6. So number 6 unit, what will happen? It will be next this one. So this, suppose we want to use this section for number 6 unit, this hole, 1 hole will coupled with 2. So number 1 unit will be first firing, after that 6, for an example, arbitrary 1 6 2 4 2 5 and 3 4 for an example. So what we'll do, for 1 unit, these 2 hole will be match. For 6 unit, this and this will be match. So 1 will be injected fuel, after that 6 will fire. So we can use any section for any unit. For 2 means the number 2 unit, we have seen the sequence 1 6 2 5. Here, this one, it means this hole will be matching with this 2. So actually we are turning the section to match the timing. And for 3, it will be this and this. These 2 will be coupled. So we'll match that way, so that any section we can use for any particular unit. So because at the exactly same angle, next unit will fire. After same angle, another unit will fire as per the sequence of firing sequence. So that angle remain actually the between the difference between the, if you see 1 and 6, what will be the difference in angle? After what angle it will fire? The 6, first 1 has fired. So that will be fixed same for 6, after that 2 and 6 will be same. And 2 and 5 will be same. Then 5 and 3 will be same. And 3 and 4 will be same. So we can, that's the reason we can do it this way. For 2-stroke engine, there are, because what happened, otherwise complete camshaft will have to change if it is integral part. Instead of that, one section it comes, and then you can fit it as per the, depending on which unit, you match the hole accordingly, and you can get it the correct timing of that unit. So it's not necessary required that a particular unit, that angle will come. It will come, a section will be sent to you and you can assemble it. Is it clear, understood, Sophonias? Tell me.
Okay, thank you, Chief. So if we have 8-unit engine, then we need to have 8 holes, yeah? If we want to use like that.
That is
Okay,
correct.
thank you.
Yeah. Then only you can use this way. And this, Tesfaun, tell me.
Sir, please can
Yeah.
you elaborate it more about the holes of the flange, because it's not, I cannot visualize it very well.
So suppose, let us see a flange here, okay? And another flange, these two are coupled together. Suppose this is two flange, one flange is this and another is this. And this flange, suppose this is one hole, this is one hole, same position. Next hole is here. Next is here. Next is here. Here and here. Now this is for an example, and here exactly the same hole you have, same angle, and it is equal interval. The angle is equal for these holes. Now, for an example, this is one. This is one. When these two holes are coupled, then that is for an example number 1 unit. And in firing sequence, after number 1, it is 6. It means for the 6th unit, 6th cylinder, this will be coupled with this. So what will happen? First 1 has fired, this will be 6. After that 6 will fire, because the cam will, position will be such so that 6 will fire. After that, this is 2. So 2 will be coupled with this hole. What we are doing, we are turning the section to make the exact correct angle, at what angle of that particular unit it will fire. So this will be connected. Next is, suppose the 5 will be connected here, and 3 and 4. So what we have done, when this 6 position, it means it is rotating, isn't it? So 1 has fired, 6 has come here, then it will have firing. After that, 2 has come here next at the same angle interval. So 2 will fire, then 5 will fire, 3 will fire, 4 will fire. Again 1 will fire, because 1 will come back here. So this different unit, depending on which, according to the firing sequence, what is the position, accordingly that section will be coupled with the next flange. So that we get any section, we can make use of any cylinder. Is it clear, Teka?
So yes, sir. Thank you. Now is clear.
Because your cam is fixed on the camshaft. So by turning this flange, you are turning the cam. So accordingly, this angle we are adjusting as per the sequence.
But sir, for the firing order, the crankshaft shape is also important. We should have to match with the camshaft. I mean that only by changing the flange of the camshaft can we change the firing order. All what we need.
Your cam and the crank, one unit if you take the reference, okay? After that, what is the angle difference? You can adjust by this. Understood? Because you have a camshaft. This is the camshaft, which is, suppose this is number 1 unit. And in number 1 unit, we know in the crank position what is the number one unit position, and your fuel cam or the exhaust and inlet is accordingly it is angled. After that, compared to that, we know after how many angle other will do the function. Then next, for an example, when you measure the crank angle, do you measure individual unit? We don't. We measure from one unit only. Then we can make out, we know what is the angle difference. Here also it is the same thing it's happening. This one unit, for an example, number one unit, we have adjusted as crankshaft, because crankshaft finally is driving this camshaft completely. So number one unit, we turn it, means we adjust it. And then respect to the number one unit, next one is number 6. Number 6 difference, this is number one unit we have adjusted from the crankshaft. After that, what is the difference between the number one unit and number 6 unit? This much angle in the firing, for an example. Then if you turn this, the flange of that number 6 unit, and you couple this and this together, when it is turned by the crankshaft, then what will happen? 6 will come to the firing position after number 1. Once the number 1 is fired, then number 6 will come. Definitely it will be, but one unit, once it is adjusted by the taken the timing with the crankshaft, because crankshaft is position is the piston position, and then next unit you can take reference of that unit. That's what we are doing here. Is it clear,
sir.
Teka?
Yeah.
Still,
Now it's very clear.
yeah. So
Very clear,
somebody
sir.
else
Thank you.
raise hand. Tell me if you have any question.
So, Chief, does it mean the construction of this camshaft for 6 units, we have 6 pieces of parts?
Yes, 6 section will be having. We call it segment. It means one segment will be from here to here, and another segment will be from here to here. There will be a flange to flange, one unit. Okay. So actually already tea time break, coffee break is past. So let us, what do you want? Let us take a coffee break for 10, 15 minutes, 15 minutes.
Yeah,
Yes,
we
yes,
take
that's
the
better.
coffee break for
Okay,
15
so 15 minutes coffee break, 45 we start again. Okay.
All right.
Again. So good morning once again, and let us start again. So we have seen the different type of construction of the camshaft, and it can be forged a single piece. Even cam and camshaft will be an integral part, and it can be in section for the 4-stroke engine. That is the flange, and there are different other types also we can have. That is, problem is the camshaft. If it is cam and camshaft is not integral part, then the cam has to move through the length of the shaft, and then it can be shrink, but it will be very, very difficult. In that case, what we do, one of the arrangement we can have is the step. So this is one step, and we can have flange here. This is for end unit. After that, you can have another one step here. Another unit, you can have one step here. Slight difference in step. It's not, I'm drawing an enlarged view to understand your. So what can happen? We can put one cam here. From this side, we are putting the cam. So this is the largest diameter, inner diameter. So we can put it here. So this is one cam. And the next cam, we can put it here. So that you can fit one by one cam here. So this we keep it a step. So there will not be any difficulties to put the cam inside, and then we can bring it here, we can expand it and put it in the last. This one easily it can come up to this, we expand it, then you put it here, then you show it. So this is the step camshaft we can make also, so that the putting the cam is easier, and the cam and camshaft can be made separately. So the cam surface, it has to be hard because the load is coming on that, and there can be abrasive wear because of the lube well, because it is lubricated. Lube well impurities also can have the abrasive wear. So cam surface should be hard so that it does not get worn out easily. And then inside should be tough. Why? Because it is subjected to the cyclic loading. It's not that the load is variation is there. When it is on the base circle, load is less. When it is in the peak, it means the flank, it will be load is changing. So there will be a shock loading. And for shock loading, we have seen that it has to be toughness has to be there. Toughness means it has to be ductile. So internally it will be ductile, tough, but surface should be very hard so that it does not get worn out. So how we do, we have seen the nitriding process. It is done by the nitriding process so that the surface become very hard. So this is one of the arrangement of the camshaft. So here you can see the bearing you can open from the side. So there are various ways you can have arrangement. Side is the easiest because you have the access cover. Remove the access cover, you can remove the bearings. So this is one of the, it means in this case, what all cam you have, that is the one, that is the exhaust. Then camshaft bearing next is shown, and then the 3 is the fuel cam, and the 4 is the inlet cam. It means this is one unit from here to here is shown, and it is supported by the 2 bearing. Like the Sulzer one also we have seen inside the cam casing, there are 2 bearing which is supporting the camshaft of that particular section. It means each section will be supported by 2 bearing. So large engine, what we do, we make the camshaft separately and the cam is separately. And cam is the nitride alloy you still because it is the surface become hard and it is shrunk fit. It means we expand it, inner diameter will expand, we put it in the shaft, camshaft, and then we shrink it. It can be done by the heating or by the hydraulic. Like when you remove, we are actually expanding by hydraulic. And when you put, we heat it and then put it. So both way we do. And the one by one, we fit it in the camshaft. It is in section, if you make, that is the advantage, so that you don't have it, cam does not have to travel long distance. So the first cam is always the longest distance. We have seen the step one. The end one, that is the first cam, it has to travel all the camshaft and then it has to be shrink fitted. So this problem to overcome, we have the stepped camshaft. Just now what I have told, this is the step camshaft we used. So that to putting to that position just before that unit, it will be easily you can fit because the clearance is there. After that, you heat it up and then you put it in position and shrink it. So to overcome that, we have this arrangement we can have. Now, if you see the profile of the cam, this is for the fuel cam, this is for the exhaust valve cam for the two-stroke engine. So this is the upstroke and this is the return stroke. The upstrokes, because the pressure should increase suddenly, so within a small time it should increase. That's why the profile is like this. After that, when it is releasing the pressure, it can be slowly it release so that the pressure surge is not there. So this kind of arrangement you can have for the medium speed engine, because in medium speed engine it is unidirectional. So we can have this kind of different. It's not required for the symmetric cam. Whereas in inlet and exhaust we usually have the symmetry. So in that case, so the opening will be quickly and the closing also has to be quickly. So that's why we use the symmetrical. So this is the, for an example, it is rotating in this direction, same direction like this other cam. So this will be the upstroke and this is the return stroke, or the outstroke and the return stroke. And this is the dowel and this is the base circle. So this is the profile. By seeing the profile, you know which one is the for the fuel and which one is the exhaust and inlet valve. For medium speed engine, we easily can make out. And for the two-stroke engine, it will be symmetric. Whereas this one, sometimes we don't make symmetric. The exhaust valve cam. That we, depending on, I think one I had explained to you that the power stroke we can increase or decrease. There are advantage and disadvantage. So power stroke, suppose increasing, then this cam we change the cam profile, because in other direction, like the reverse direction, it will be running for very little time compared to the head direction. So we considered in head direction what is the maximum benefit. So accordingly, we make the profile, cam profile. Now, our cam is always shrink fit. We don't use the key and keyway because that is the stress riser. The crack can develop. And medium speed reversible engine camshaft. Like exactly the same one the Mitsubishi uses. Mitsubishi uses the shifting of the camshaft shift axial. So medium speed also is uses some medium speed. You have speed engine. You have the reversible camshaft reversible engine. For the main engine, it is provided for the your emergency purpose. If it is a main propulsion, it is provided some engine with the emergency purpose. Suppose your CPP is stuck, then you can reverse the engine in case of emergency. But normally it will be running in unidirection, one direction. So how it is done? It means our camshaft, suppose we have two cam side by side for fuel, and for inlet, outlet, inlet and exhaust also, we have two cam. One cam is for the head direction, one cam is for the astern direction. And then actually if we shift the camshaft, then what will happen when it is running in astern direction, it has shifted and the roller follower is in contact with the reverse cam. So that is the way Mitsubishi does, and the two-stroke, four-stroke engine they do, and it is hydraulically shifted. Let us see this diagram; it will be very clear to you. Description is same. So here we have two cam. You see one piece, there is two profile. One is this profile, another is this profile. And if you see this diagram, it is a smooth transition. When it is moving axially, it will not get obstructed. There is no steps. It is a smooth, slowly there is a slope. and then it's changing the, shifting it to another cam. So this cam is always in pair. Two cam profile is together. So how it is moved? The actually hydraulically. It means when you want to put it in the stern direction, suppose this is the head direction, then this side hydraulic pressure we apply, and this is getting drained out. So this piston, hydraulic piston, will move this direction, and this oil is system oil. And then this cam will move this direction, and this cam will take the position. It means the follower will be in contact with this cam, so that the engine can be reversed. And this gear, it is for an example, Mitsubishi, they use the gear drive for the two-stroke. And the four-stroke, suppose it is gear drive, we have seen the gear drive, gear is profile is involute profile, and the parallel face, it is the straight face we make, so that the shifting of the cam will not have any mechanical obstruction. It will move, but there will be a rubbing effect on the surface of the flank. So this is the way the reversing is done for the two-stroke engine, as well as Mitsubishi use the same system. They use the same system for two-stroke engine reversing of the camshaft. Is it clear, everybody? Let us see the description. It is the same thing is written. When there is it is driven by the controllable propeller when two-stroke engine is used for the main propulsion, and it is directly coupled with the, and it is not directly coupled with the propeller, but propeller is through the gearbox, because propeller RPM, lower RPM is efficiency is high. That's why we need to use the gearbox. And then the CPP, it is controlling the ship speed. That is, pitch is changing. So, but we can have for emergency the head direction. In that case, we need to reverse the engine. That is, this is the way reverse direction engine oil pressure. It's shifting the hydraulic piston. The camshaft is shifted axially, and the reverse cam is in operation in contact with the follower. So engine can be run in both direction, ahead and astern direction. And this the smoothness of the shifting, that is, this is called ram. This, so that from here it shifts to this, and from here it shifts to this. This surface is called, it is an inclined surface, it is called ram. So you need to have a ram. You cannot have this step, then that will damage your roller, and the cam also will get damaged. Is it clear, everybody, what I have taught till now? Because this is the last portion. So four-stroke engine also we can have the chain drive and the gear drive, both we can have. Okay, let us before we close, there are a few slides. Now tell me, suppose a cam is damaged. What will you do? It happens, but it rarely happens. It's not something happens every day, and many people might not have seen in his life. It did not happen in his during his selling. It also possible, because these are the rare things it happens. So suppose the cam is damaged, then what will you do? It means that unit you cannot use actually if it is badly damaged, because that unit timing will be entirely different. So and suppose it is shunt fit, and it is in a position where it's difficult to take out, and it is a four-stroke engine. It is you need to take out all the cam to take out that. In that case, what will you do? Have you understood? We can remove the cam and we can change the cam, because cam will have the marking and shaft will be having the marking, so we can match that. It means if you have a cam, for an example, this is the cam shaft, and we have the cam, so there will be a marking. So this is the camshaft, and on the camshaft there will be a marking, and the cam there will be a marking. That is the match. Match mark, so that if it can happen that cam and camshaft is not an integral part, cam can shift. So this mismatch, by this mismatch we can find out. So now cam has damage. Now we'll have to remove all the cam, and then we can remove. If it is not a single piece, the cam is different and the camshaft is separately made, we can expand it and we can remove it. But suppose we have cam location is such that we'll have to remove many cams, which is practically it will not be possible. The camshaft has to be removed and sending to the, in that case, it will be difficult in sending to the manufacturer's workshop, and then they will take out one by one. Instead of that, what they do, they supply, we can cut it, that particular cam. So once we cut it, we can cut like this. But you be very, very careful when you cut it. When you are cutting, that time camshaft can be damaged. So camshaft should not be damaged. You must cut it such a way. Once we cut it, after that what will happen? The maker, now all the cam is in place. The particular cam which is damaged, we have removed it. Now the maker will send a cam in two piece. Cam also they can manufacture in two piece. It means this cam we have in two piece. And then this two piece is secured by the bolt. And this bolt, how much will be the torque? It will depend on that friction brake. So they manufacture such a way that they will give you the torque tightening. Once you tighten by the torque, with that torque, there will be a compressive force inside, and that force will be sufficient to keep it in grip. But what they will tell, they will derate the engine. It means till the permanent repair, you'll have to run it at reduced RPM, reduced load. So this is one way we can replace the cam, and many four-stroke engine, the main propulsion, it is done this way, because main propulsion ship is still in operation with little less RPM, because it is a constant speed RPM. This is a constant speed engine. We are changing the ship speed by the CPP. So instead of, for an example, it is the 800 RPM. So we reduce to 700 RPM. So, but still the ship can move, ship can operate. So this is one way it can be done. But the only thing what I told you, that when you cut it, you should be very, very careful. The camshaft should not get damaged. Slowly you cut it, and at one point you'll see it become weak, and you can break it. You can remove it. So this is the way it is removed, and new cam you can, and after that ship goes to the dry dock, and it can be, dry dock has got time, the permanent repair can be done. It means the manufacturer authorized workshop will take it, and then he will replace a cam. This cam will be removed, and other new cam will be replaced. Then there will be that restriction of the speed, RPM will be removed once the permanent repair is done. Is it clear? Understood? Yeah. Somebody raise hand. Four of you. Tell me one by one.
Okay, Chief Smarlasa.
Yeah.
Can we use this kind of temporary repair on this on the generator's camshaft because we cannot reduce the RPM?
So camshaft means the generator. Usually we don't do. It is done for the main engine, because generator. Number one, it is the construction. It is a small compared to the main engine. It will be a smaller engine. There, the camshaft construction is different. Usually it is a same. It is forging is done together. And also RPM, if you reduce, then what will happen to your voltage and all? Understood?
Everything will be affected. Yeah.
So it is done in the your main engine. Main engine, if it is a 4-stroke engine, if this problem comes sometime, but it is not an everyday problem, but sometime it happens. So others, I think total 5 of you raise hand. And so other, what is the question? Tell me.
Chief,
Yeah,
Sophonius speaking.
yeah, tell me.
So we are drilling this cam, or how we are connecting it? I didn't hear it because it
No,
was
say again.
connected. How we are connecting back the cam?
This
By drilling.
cam, are you talking about? Are you talking about 2-piece cam?
Yeah.
Which temporarily it is supplied by the maker. So this will
Yes.
stop.
Yes.
Say, have you seen? I have drawn a vertical line. This is the first inner bolt. So when you assemble, exactly we have the match mark. On the match mark, we put and then we tighten.
Okay. If it is like this.
Yeah. And there will be torque. Torque has to be maintained to achieve the correct interference, the grip.
Okay. But if we are drilling on the surface of this profile, then
No,
we are
it will
going
not be
to
drilled. It will come with the hole. And this hole, if you see in large view, it will be like this portion will be like, our hole will be like this. So the bolt will be inside and will be tightening. So it will be not projecting out.
No, yeah, I know it will not project out, but are we going to fill up this hole, or is it not going to be on the profile? Because otherwise we are going to damage also the follower.
But this will be, this portion, it is on the base circle when it is coming, that is the, you are talking about, but it is made such a way, this portion will become smooth. There is no filling. It will be like this. But this profile will be, it will be all matched with that base circle. And this surface of the, it means this surface, there is a head. So that head will be such a way so that it will be on the, it will match with the profile. And it will be very little gap actually. This bolt head will not be too wide actually. They made such a way so that this profile, it will match, it will not interfere, it will not damage the follower.
Okay.
But there will be a little change of shape, but that will not affect. It still can run. There is no problem of running this in this condition.
Okay.
And what they make, they put this 4 bolts at the side, and your follower is at the center. So this, if you see this, this is the bolt, 1 bolt, this is 1 bolt, and your follower will be here. This space will be used by the follower. At the side they make. So it will not be, its profile will maintain.
Yeah, this was my question. Okay, thank you.
So any other question on this chapter? So if we'll start the next chapter, that is the starting and
Yes, Chief.
Yeah.
Chief, this is David. So, Chief, for example, if we cut this camshaft and remove, but instead of putting back another 2 split type of camshaft,
yeah,
why we don't just shut off the fuel for this?
Yeah. So what we are talking, why don't you cut off that unit and run the engine? So that is not advisable because your engine, that is for emergency only. So your engine will, vibration will increase. There will be many other problems because of the cutting off. And this engine is constant speed engine. So you will be running at higher speed. Unlike the two-stroke engine, you reduce the RPM because it is variable speed. So this engine, always the four-stroke engine, if you cut off, then the imbalance effect will be very, very high. So that is only on emergency purpose we do it. But we want to run the engine till the permanent repair. We cannot run one unit cut off for long time. That is for the short time we do. And four-stroke engine, it will have more adverse effect than the two-stroke engine because it is running at high speed. Understood? Clear, Dev?
Yes, Chief. Thank you.
So if no question on this chapter, then let us start the starting and reversing. So this is another important chapter, that is the starting and reversing of the engine. It means it is a reversible engine. That's why the starting and reversing. Now, what happened actually when we want to reverse? So there is one terminology, it's called lost motion. What is lost motion? It means when engine is running in a head direction, so the cam has got a particular angle relative to the crank angle. At position, the correct position, depending on the crank angle, then for an example, the fuel will be injected on time. Let us take one example that the 10 degree before TDC, the injection start, fuel injection. And it continues until 10 degree after TDC. And after TDC, it will depend. We have taken an arbitrary angle that is 10 degree before and after 10 degree, it will be TDC, it will be after TDC, it will stop. The injection will continue until that. Now, if we look at this condition, let us look at this diagram. Now, camshaft is rotating in this direction, cam also rotating in this direction. So what is the position of this? What we have considered 10 degree before TDC injection start. When the injection will start? When this is the follower is moving upward direction. On the base, it was on the base circle. It was not, there was no vertical displacement when it was on this circle. But the moment it's on the flank, it is just move it onto the flank. It has started moving, the pressure is increasing, your injection start. So in this position, this is the 10 degree before TDC. It means if you see this diagram, this is the TDC. It means 10 degree before TDC, this is the position of the piston. And the injection starts. Now suppose we reverse it, then what will happen at this position? It means at this position, what I have drawn, it is the injection just started. That is the 10 degree before TDC. And this is the cam position when it is started the injection. Now suppose we reverse it, then what will happen? So we have reversed it. What is the position then? This position is same. It is the 10 degree before TDC. This position remains same. When we are reversing, what is this position? This position 10 degree after TDC. Isn't it? Have you understood what I said? In ahead direction, this is 10 degree before TDC. Now we are rotating in reverse direction. It means it is already past TDC. TDC is this. So this was before TDC for this direction, ahead direction. Now we have reversed it. It has become 10 degree after TDC. Isn't it? Have you understood clearly what I said?
Yes.
Yes, Chief.
Now that is the problem. What is the problem now? If we run the engine in this condition, it means this is become the end of injection. Once it has become end of injection, it should be here. So when it is reversing, it means if this follower is here and it is reversing, what will happen? This follower will have a vertical motion and injection will be starting. And at this point, the moment it reaches this point, what will happen? Your injection is stopped. Injection can be stopped before that also, but I'm not talking about that fuel pump. But from the fuel pump, you can stop it. Now, this when it is rotating in opposite direction, if your follower is in this position, when it is rotating in this direction, follower is in this position. Are the same position now? Because that time only the follower will move upward. Here it is moving in this direction, that's why follower is moving in upward direction. So whereas if we turn it in opposite direction, this will come to the base circle instead of going to dowel. And then it will come to the return stroke and then it comes to the base circle. So this position is not the correct position. So that's the reason we need to change the position of the cam relative to the crankshaft. And then we can have the correct position of the cam for the fuel injection. So if we see this description, so in this description, so we have considered one particular unit, one of the unit, and it has stopped the unit at that position. So which was now become, when we are turning the engine at ahead direction, it had stopped here, for an example. So it was before 10 degree before TDC. Now if you want to turn it in reverse direction, then what will happen? It means when it was in the means the ahead direction, what had happened? This was moved in this direction and then it come to the down. After that it moves this direction. So this is the outstroke. After outstroke down and then it comes to the return stroke and the base circle. That's happening when it is in ahead direction in this picture according to this diagram. Now it means the injection will stop when it is reaching to the down if the cam is controlling the injection. So now if we reverse it, then what will happen? That is 10 degree after TDC because the TDC is already passed if you are rotating in opposite direction. It means at 10 degree we have considered the end of the fuel injection. So once end of the fuel injection at 10 degree, but here it had happened here. But here it is happening here if you turn it in opposite direction. So that is the 10 degree before TDC. So that is the completely the cam is out of the timing. So that's the reason we need to turn it to a certain angle. We'll see how much angle we turn it so that it comes to the correct position relative to the cylinder angle. What is the piston position or the crank angle? So this is completely out of time with the engine. What if we turn it in a astern direction, keeping the cam at that position? So what we do in that case, so now tell me how much we should turn in that case. It means we'll have to turn, that we come to. So, but how much we should turn? Means it turns by, or it turns automatically because it is designed that way. But how much should it turn? Now, let us see one thing. Suppose our engine is at TDC. So this is the base circle of the cam, and our engine is at TDC. So our cam is like this, and it is a symmetrical cam. And at TDC, the follower position is here. Suppose follower is here. And this is the cam profile. It means at TDC still the follower is not on the dowel. It's on the outstroke, on the flank. Because after TDC, the fuel injection continues. If at TDC it is at this position, fuel will not continue, injection. So somewhere here, let us take at this point at TDC. Now, what will happen? We'll have to turn it. We'll have to bring this to this side when we are reversing. So how much we turn it, it means that is the how much motion we lost, because we already the position of the cam was here in ahead direction, but we are moving the cam in opposite direction. So what we'll do, it means for an example, our follower is here only. We are not changing the position of the follower. What we are doing, we are changing the cam position. In that case, we'll have to change the position in this direction. So what we do, this is the cam, and for an example, this is the cam. So it means when it is rotating in this direction at TDC, it was in this position and injection continues. Now I have turned this much angle. This is the angle theta. And this side has come here. This is the, it was the outstroke here. Now it has become the, this was return stroke, and this has become the outstroke for reversing of the engine. So what I have done, it was here and injection continued because it was before the dowel. Here I have turned such a way so that it is on the outstroke but before the dowel at the same position. Now if we turn it reverse, is it okay? Tell me. Have you understood what I said? How much angle we need to turn? Because cam has to turn. Yeah, Sophonius, tell me.
Okay, thank you, Chef. What I was understanding, we want to bring the follower to the other side of the cam profile. But if we are turning again in the same direction, this means we are injecting fuel into the unit, which means we are not reversing. We need to turn the cam to the other side, not to the smallest angle, but to the other, to the bigger angle direction. I mean, through the base circle.
So let us see this. This is the cam, and this is the flank. So when it is rotating in this direction, this is the outstroke, this is the return stroke, and our follower is here because it is at TDC. Unit it as TDC. At TDC, follower is here, and it is rotating in this direction. It is still moving up, so the injection will continue. Now, engine, for an example, has stopped at TDC. What will happen at TDC? Our follower position is same. In this case, the follower has to come here, because when we are reversing it, it is changing the outstroke will become the return stroke will become outstroke. So now, for an example, this is our cam. Okay, here this was the return stroke, whereas this is the outstroke because it is rotating in opposite direction. And this is the return stroke, whereas here it is the outstroke. That's the reason the injection did not stop at TDC. It continues. Whereas, suppose we turned it at an angle, it means this is the angle we have turned it. This is theta. This position remains same. And we have turned it, and this is the position of the follower now, and this is the vertical motion. Now we are rotating in this direction. This is at TDC because engine position is same. We have stopped that particular unit at TDC. Now, if we turn in this direction at this angle, is it okay now? At TDC, because it has started at 10 degree before TDC, and then it reaches to TDC, and it is symmetrical, this cam. Now, it will continue after TDC or not? Have you understood? This is, because this was superimposed, this diagram. That's why I separated. Yeah.
I understand the concept.
Yeah.
My question is, we should not turn the amount of theta. We should turn 360 minus theta to the counterclockwise. Otherwise, we want to start the engine and we are injecting in the unit's fuel. And then we are starting again. So this will be bad, yeah?
So are you talking about the direction of rotation?
Yeah, we need to turn.
No, it will be, there will not be any problem. It will be in this direction, it is turned. So it will not be what you are thinking, that you will be turning in this direction, isn't it? That was actually your question.
Yes.
But we turn it this way, there is no problem. Even the engine is designed such a way, it can be turned when engine is running. And there are other interlock. You do direction interlock, we know. Now we'll see that it is in your syllabus. So this is turned this way, and this theta will be our lost motion, and there will not be any problem. And best position to turn it when engine is stopped, because when you are reversing, That time actually engine has to come to 0 RPM. Then only it will reverse. But it is designed such a way, even still when it is rotating and it is still can be turned. But the best position is when engine is stopped. Then the camshaft, which means this cam is moved. So this is the concept of lost motion. Why we call it lost motion? Because it was turned at this angle already, but we have moved it back for the reversing. That's why this much motion is lost. That is the reason we call it lost motion for the reversing. Is it clear, the concept, everybody? Because it's very simple of understanding. Once you understand, you'll never forget. So this is the way Sulzer does. Sulzer conventional engine do the reversing this way, reversing of the cam for the fuel cam. Exhaust valve you don't need, they keep symmetrical. Exhaust valve is symmetrical, even so there is no the same degree it is actually closing and opening. But here it can change depending on the engine load. Your end will change. How much quantity of fuel is injected. So,
Jeff, sorry again.
yeah, any question?
So this means every time before we reverse
Yeah.
our engine, in some units we are injecting fuel without any firing. Yes, in this case.
This is during, if it is happening during the running, then that problem will be there because your engine is still rotating in opposite direction. That's why the best position is stop the engine. It changes the, for an example, if you are having the crash stop, that time fuel will not be injected because it senses the running direction. Once you reverse the engine, air will be injected, not the fuel. There is an interlock. So engine will not be damaged. Have you understood that? Because there is, see, when it is position has changed, there is a signal is coming. What is the position? Is it reverse or ahead? So the moment your running direction of the engine is opposite to that, the fuel is cut off. And air will be, but whereas the air will be injected, but not the fuel. When you have changed from ahead to astern, definitely there is a starting procedure has to be followed, isn't it? Before it inject the fuel. So that interlock safe. But what is the, like when it is changing, that time the power requirement will be less when it is not rotating. So Sulzer they uses for the conventional engine. That is the this is the mechanism they use for reversing the cam. It means reversing the engine. For the fuel injection system, they change the timing to the correct timing for the reversing. Now, for the starting, our starting is we two-stroke engine. We start by the direct air injection. So, what is the direct? Once the compressed air is admitted, then what happened actually? Once we reverse, it means we have to suppose start the engine. So, if we see our angle, this is the timing diagram. In the timing diagram, we have, this is the TDC, this is the BTC. And our fuel injected 10 degree before TDC for an example and ends 10 degree after TDC. And then our power stroke. It ends the moment exhaust valve open at this point, our power stroke is end. After that, here we have the exhaust valve closes. This one is the exhaust valve close and the inlet port opens here and close here. And then this is the compression. So when we inject air 5 degree after TDC, around 5 degree. So we inject air from here and up to just before the exhaust valve. So our air injection from here to here. Once we inject the air here, what does it mean? This was the power stroke or the expansion. It means now there is no fuel. We are injecting the air, and air is injected with 30 bar pressure. That is the maximum pressure we do use. So that pressure is actually forcing the cylinder in moving downward and crankshaft to rotate in desired direction. So this is the injection timing for the starting air. Compressed air is then it is giving us the power. It is not the fuel which is giving us the power. So now what will happen if we rotate in, suppose when the engine is running, like let us see this, engine is still running, then what happened actually? Engine when it is running, for an example, this is running in ahead direction, this is the direction of rotation. And now engine has reversed. We have reversed the engine, and once we have reversed the engine, what will happen? Engine is still rotating in this direction. It has not changed the direction of rotation. Because for direction of rotation to change, engine has to stop first. After that, the air has to inject at the correct angle. After that, fuel has to take over from air to fuel. After that, the engine will run in astern direction. So now we have changed the reversing mechanism because we have given command for the reverse. But engine is still rotating in this direction. In that case, what will happen? It has changed the direction. Suppose we have a valve timing, this is a timing diagram where we have seen this is the TDC and now it is rotating in this direction. This is the power stroke from here to till the exhaust valve open. This is the end of the injection, and after that the power stroke start because now it is rotating in this direction, and this is the fuel injection start here, and this side is the compression. Now what will happen? The reversing gear has changed already. Once the reversing gear has changed, what is the timing for compressed air to injection? 5 degree after TDC. Now this has become 5 degree after TDC. In this direction, ahead direction, this was the 5 degree after TDC. It means it was here. And now it is here. So what will happen? Air will inject from here to here, just before the exhaust valve opens. But our engine is running in this direction. Then what will happen? This injection will start here, end here. This is the exhaust valve opening just before that. But when engine is running in this direction, what is this? Is it power stroke or compression? This is compression stroke. Then what will happen? Actually, it will affect a braking effect because engine is trying to rotate in ahead direction because still it is rotating in ahead direction because of the momentum. And we have injected, our reversing mechanism has changed. But because of this running direction opposite, fuel will not be injected, but air will be injected. Once the air inject, what will happen? It is like piston is moving upward direction during the compression stroke, air is injected. Because air is injected now in compression stroke. What will happen? This will try to oppose the movement of the piston, upward movement of the piston, and it will have a braking effect. In that process, what will you achieve? The engine will come to the standstill position, that is 0 RPM position. Then, once it is come to the 0 RPM, then it will start rotating in opposite direction, because then the correct angle of expansion stroke, the air is injected at the correct position. It means the unit which is in this angle will get air. But whereas when it was rotating in opposite direction, that is during the compression stroke, it was injected, it has had a braking effect. Because of braking effect, it comes to 0 standstill, and after that the reversing will start. It means after that the engine will be rotated by the compressed air, because now this timing is correct, and then it will start rotating in opposite direction, and then it will change over to the fuel at correct RPM. Is it clear, all of you, what I said? This happens when you get a command of crash stop. Panama Canal, those have crossed. You know, many canal it happens because there is a convoy, and so suddenly the speed has to be reduced. You get command, you get the order for full ahead to full astern. When you do this, still engine is running in ahead direction, and this compressed air is injected, which gives a braking effect. After that, compressed air continues. Once it stops, it's injected in the correct angle, and then it starts rotating in opposite direction, and then it picks up on fuel. So clear, understood how it happens, what happens actually when engine is rotating in opposite direction and air is being injected, because you have reversing mechanism already is in reverse position. Yeah, Melissa, tell me.
Okay, Chief. When we make this like crash stop,
Yeah,
the starting valve, the air starting valve, will remain open until the engine stop and again start, or it's just breaking the movement until stop and then again another injection to start it. It's not clear for me.
which air you're talking about? Air starting valve, main air starting valve, or the cylinder air starting valve? Yeah, Melissa.
The cylinder air starting valve.
Yeah, cylinder air starting valve will open at this point, this angle, and close air. So individual unit, each unit when it is at this point, 5 degree after TDC, injection will start, and just before closing, around to 3-4 degree, it will close. So that timing will be maintained for individual cylinder. So it will not be continuously opening. It means if continuously opening, only thing because of the direction of rotation was wrong, that's why this was in the compression stroke, if you look at the direction of rotation. And air was injected from 5 degree after TDC up to here. Whether it is rotating in clockwise direction or anti-clockwise direction. But when it is in clockwise direction, this is the compression stroke, it has a braking effect. When it is rotating in opposite direction, it will be correct, it is actually power stroke that time. So it will rotate the crankshaft. It will be open only during this angle. This angle, your cylinder air starting valve will open. What will happen? It is injecting when it is rotating opposite direction also, and it is giving a braking effect. After that, it will stop because of this braking effect. Once it stops, it will continue injecting. Understood? So it will not stop injecting. So it will continue injecting, and then it will start rotating in opposite direction, because the start you have given the command from ahead to astern. It means you have crossed the your you have crossed the stop and then start. And when you are putting into the astern position, it is starting circuit is on, active in ahead astern direction. It means sometime, for an example, let us take this way. On the ship, suppose you have telegraph is independent of this control. What the telegraph is doing, when you accept the telegraph in the control room, that time telegraph only changing the reversing mechanism. It does not start. You have another starting lever which is start, that is the stop, start and fuel. So in that case, what will happen? You have received the order from ahead to astern, you have changed it to astern, from ahead to astern. What had happened? Your reversing gear changed to astern because telegraph is controlling that. And then even it may have that telegraph is not controlling, telegraph is only the communication for the moment. You can have a separate knob to change over ahead to astern. But let us take that telegraph has changed to from ahead to astern. Now, what will happen? After that, because you have got a command, it means you'll have to miss from ahead to astern. You'll have to quickly give. So what you do? You put it to start. In that, engine had not stopped. Engine is still running to the opposite direction. Once you have put it to stop, it means once you change to the reverse direction, automatically there will be one alarm will come. In that situation, wrong way alarm. But you can ignore that because it is normal. Once wrong way alarm has sensed, then what will happen? Fuel is cut off, but still engine is running because of the momentum. Then you give in that condition, you give the start from the start lever. It was in the fuel, you bring it to stop and bring it to stop and you give to the start command. Once you have given the start command, this thing will happen because your reversing gear has changed already because of your telegraph, because telegraph is controlling that. And now you have given the start. Once you given the start, then this will stop because of the braking effect. And you still keep it on start till it reverses it. So it will keep on continuing injection of the air. And then once it is rotating in opposite direction, then you change over to fuel. And this we'll see at particular RPM actually we change over to fuel, from air to fuel. So this you are doing manually. In the control room, any ship has got this type of arrangement. It is telegraph is directly, it's not controlling the starting, stopping and the fuel. But you can have bridge, it is telegraph itself is doing all the control. It is not only communicating. In that case, what will happen? From ahead to astern, it has put. The moment it has put to astern, the telegraph reversing mechanism has changed over to astern, reverse direction. But your engine is still rotating in same direction, ahead direction. So wrong way, because of the wrong way, fuel is cut off. But what will happen? Since the telegraph is on the astern, it has crossed stop and the start. It means when you put it on the astern, automatically it will try to give the starting is the reversing, that is the injection of air will start. But fuel is not there because fuel will cut off immediately. The moment you put the telegraph lever from ahead to astern and engine is rotating in ahead direction, fuel will be cut off. But air will be injected. Air will start injection because wrong way in air starting system does not have any problem. Fuel will be cut off. So it will keep on injecting the air, and when it is rotating in ahead direction, it will have the braking effect. It will stop at one point. It's still trying to inject because it will keep on trying to inject because the engine has not actually reversed and taken over to the fuel. So it will stop. The moment it stops, the angle will be correct. The injection. Now it is in the expansion stroke. And engine will start rotating in opposite direction. After that, it is same. At changeover RPM to the fuel will be injected automatically, and the engine will be reversed. Engine will start rotating in astern direction. You can have in the control room also exactly same what the bridge has got. Bridge has got only telegraph that controls everything, start, stop, as well as the changing of the air to astern direction and fuel control, all control in one lever you can have. So it is the same, whether one control one lever, or you can have telegraph which is controlling the air astern mechanism, and you have the stop, start, and the fuel is separate lever. The principle is same. Is it clear, all of you? Yeah, Teka, tell me.
Sir, when is crash stopping? I mean that you said that the starting air will be supply when the piston is moving up, yeah, moving to the top dead center. So let's say, for example, if the pressure of the starting air is about 30 bar, and then the piston is also moving to the top dead center, so the pressure will increase. Yeah. So at that time, the burst disc will not be affected, or some damage will not happen to the engine or to the cylinder head like that.
Yeah. So it will not be, because the excess pressure will come out. Your air starting valve is open. Through the air starting valve, that's why when crash stop, you'll see the air starting line, there is a relief valve, that relief valve lift. Because the excess pressure, your starting air valve is open. It is on the compression stroke. It happens. What you are saying is, you are absolutely correct. So the pressure increases because of the compression. And excess pressure, what will happen? That moment, your pressure will be released through this, because the 30 bar pressure is your air starting pressure. So the relief valve, which is located in the air starting system, which will lift and release the pressure. If your relief valve, if your then also you have the cylinder relief valve. So if your suppose there is no space to escape this air, then it might be, because if your cylinder relief valve also lift sometime during the crash stop, that is the reason. And once excess pressure is relieved, then, and if it is cylinder relief valve, suppose it not lifted, it means it is within that pressure inside is within the safe limit, because you have a cylinder relief valve that will take care of it. And also the excess pressure goes to the air starting line. That's why sometimes you'll see air starting line, the relief valve is lifted because of that reason. Is it clear? Understood, Pekka?
Yes, sir. But I don't know. I didn't see in the starting airline. In the starting airline, I think there is only burst disc. Yeah. Is
Not
there any
necessary.
relief valve?
BMW uses bursting disc, but the Sulzer uses the relief valve.
Okay,
so
sir. Okay.
in that case, what will happen? Your relief valve, cylinder relief valve will lift, and it is normal. You should not be worried about that. If cylinder relief valve lift, or the Sulzer, they uses the relief valve on the air starting line, so that will lift. So these are the normal thing will happen, because why crash stop is given, there is some emergency, that is the reason, otherwise ship will collide, that is the reason. Yeah, Teka, tell me.
Thank you, sir. I already get the answer.
Yeah. So
Chief,
yeah, tell me.
that means, let's say we put to the dead slow or even slow start.
Yeah.
So that means once the engine is already stopped, and then start to rotate on the reverse direction.
Yeah.
So this time will continue in slow direction with fuel without even putting back the telegraph to stop. That means.
fuel is after that. Once it is the moment you telegraph goes to reverse direction, your fuel is cut off because it is running in opposite direction. After that, it will stop.
Yes, it will
Fuel
stop,
will,
and then
yeah.
uh,
Tell me.
what I mean is, let's say,
You're coming broken. Say again.
in
Can you
certain
text me?
direction
You're
when
not
we
clear.
go to
Send me
slow.
by
Then,
chat.
okay, can you hear me now?
Yeah, now I can hear you clearly. Tell me.
Yes, Chief. What I was saying is, let's say we make a crash stop, and then we put the telegraph to the slow ahead, slow astern.
Yeah.
So the engine will come to stop, and then the fuel will start to give without even putting back the telegraph to the stop while it is still in the slow direction, in the slow command.
So you have put the telegraph to dead slow, for an example. Whether it is dead slow, whether it is slow, half, does not matter with the starting system. It's the air system, air injection system. Only that matters the fuel, how much quantity of fuel will be injected. Now, once you have crossed from ahead to astern, you have crossed the stop, isn't it? Already. Because
Yes.
you have crossed the stop and then you put it to astern. And the moment you put the telegraph to the astern, if telegraph is controlling the complete starting system, then what will happen? It will keep on injecting the air to turn it in right direction. And once it turning into the right direction, then that interlock, running direction interlock automatically will get resetted. So it gets resetted automatically. So that interlock will be only for the wrong direction of rotation when it was running in air direction. Now it is this normal procedure it will follow. It will reach to the by air, it will reach to an RPM, which is the changeover RPM from air to fuel. Then air will be stopped and the fuel will be injected. And depending on the position of the telegraph, it will control the quantity of fuel. Because the moment you have put it to the astern from ahead, it had stopped, cross the stop, and then starting sequence started again. So during the starting sequence, it will keep on trying to rotate in the right direction. And once it has come to the stop and then right direction, after that, the running direction interlock will be resetted and the fuel will be injected at that particular position. Position means RPM. So that's the way it will rotate in required RPM depending on the telegraph position. Because if you have that control telegraph, you'll see there is no stop, there is no start written there. What is it written? Stop, ahead direction you have written, and reverse direction it is astern direction. It is written dead slow, slow, half, like that. So once you move from stop, any position, your starting cycle will start. Unless you have a separate lever, that which engine room has got. Many engine room has got a separate lever, stop, start, and fuel. But the telegraph, when you are talking about, it is starting cycle will start the moment you move from stop to other direction. It means it was running in a direction. You have crossed the stop. After that, it changed to astern direction. Your fuel will cut off because of the running direction, but starting cycle will start because you have moved from the stop to the other direction. Is it clear, understood?
Yes, Chief, it's clear. Thank you.
So, is there any other question? So, if no question, then we'll stop it here and next class will continue from here. So this is yeah. Okay, then let us take a break. Yeah, let us take a lunch break then. Okay, so bon appetite to all of you.
Thank you, Chief.
Chair.
Thank you.
Thank you.
Okay, good appetite.
Yeah.